Today we're going to again solve some linear systems and three-dimensional systems using matrices, although it's going to be probably a little bit different than last year. Last year I know you plugged a lot of stuff into your calculator, hit a couple of buttons, and went ahead and solved it. Today we're going to use some new methods to go ahead and solve these systems using matrices that are not going to be calculator based. So let's go ahead and do that now. First of all, every linear system can be written as what's called an augmented matrix. And you can see here I've got a three-variable system, and I've written that system into an augmented matrix form. You'll notice in the left-hand side of this matrix I have all the coefficients, and they call that the coefficient matrix. And the right side I have the solutions to the systems of equations on the right, or what the equalities. Matrices are notated by their rows and their columns, which go up and down. And when we do operations on augmented matrices, there are these things called elementary row operations. And when these operations are performed, the result is we get back systems of equations equivalent to our original system in our original matrix. So one of the things we can do is we can interchange any two rows of a matrix and have the same system that we started with. We can take and replace a row by any non-zero multiple of that row. In other words, if we go back to thinking of systems of equations, you can multiply either side of the equation by the same number. Lastly, we can take and replace a row by the sum of that row and a multiple of another row. And that's kind of like the elimination process of solving systems that we did before. Now, as far as augmented matrices go, there's a form called row echelon form. And row echelon form, it's easier to look at it first and then describe it after. This is an augmented matrix in row echelon form. Notice the highlights, the diagonals of 1. We have some variables A, B, C, and D, E, and F, which represent constants on the right-hand side of that. And you'll notice that we have this kind of stair-step method. So let's take a look at what it means to be an augmented matrix in row echelon form. The entry in row 1, column 1, which is right here, has to be a 1, and only zeros appear below it. And then the first non-zero entry of every row thereafter has to be a 1, and only zeros will appear below that. So if I have a 3 by 3 as my unknown matrix, then I'm going to have 2 zeros, 1 0, and then the constant 1 at the bottom. And then any rows that contain all zeros to the left of the vertical bar are going to appear at the bottom. That's not the case in this one, but I could have an all zero row and it would have to appear down at the bottom. So now what we're going to do is we're going to, first of all, take this 2 by 2 system, transform it into an augmented matrix. You can see the coefficient matrix of 1, 1, 2, and -3 mirror the coefficients of this. And then on this little picket fence, if you want to call it that, we have 6 and 2, which are the solutions of this system over here. And we're going to transform this matrix into a row echelon form of an augmented matrix. It's going to look like 1, a 0 below it, some A, B, and C value here, and then a 1 in that second row by using these elementary row operations. So since I already have a 1 here, all I really need to do is make this term a 0. Now I can do that by multiplying my top row by -2 and adding it to this bottom row and replacing that bottom row. That's one of the things that I could do by elementary row operations to get the same matrix back, or an equivalent matrix, not necessarily the same. So in order to do that, what I'm going to do is I'm going to take 2 times row 1, add it to row 2, and replace row 2. That's how I write that. So in doing that, I multiply this term, we'll multiply by -2, sorry about that, by -2 and add it to this bottom row. Multiply this by -2, add it to 2, I get 0, which is what I wanted. multiply by -2, add it to -3, get -5. Multiply by -2, add it to +2, get -10. And then what I need to do to get it in row echelon form is I need to make this term a +1. And that's pretty easily done. Notice my top row is okay. So I'm just going to recopy that, 1, 1, 6. To make this row lead with a 1, I'm just going to take and multiply -1/5 times row 2 and replace row 2. When I multiply 0 by -1/5, I still get 0. Multiply -5 by -1/5, I get a +1. Multiply 10 by -1/5, and I get a +2. Now notice what I end up with. I end up with a y value equaling 2, and then I have this system over here that's really x plus y equals 6. So if y is equal to 2, x is equal to 4. And now I have a solved system using these elementary row operations in this 2x2. Obviously 2x2s are easy. So what I've done in this last example is I've taken a 3-variable system, written it in augmented matrix form, and shown the steps of reducing this augmented matrix to a row echelon form matrix of this 3-variable system. So you'll see I've kept my first row the same throughout because it leads with a 1. I need to get zeros below the 1 in order for it to be row echelon form. And if I take and row 2 subtract 2 times row 1 from that, I'll achieve that step. So if I multiply this by a -2 and add it to 2, I get a 0. Multiply by a -2 and add it to -1, I get a -5. Multiply by -2 and add it to 1, I get a -5. Once again, multiply by -2 and add it to 8, and I get -10. Next, I'll take, since I need to get rid of a +3, I'll multiply row 1 by a -3 and add it to row 3. So once again, multiply by -3, add to 3, I get 0. Multiply by -3, add to 0, I get -6. Multiply by -3, add to -1, I get -10. And multiply by -3, add to 3, and I get -24. So now you'll notice my first step is complete. I've gotten zeros underneath the 1. Now I need to get a 1 in place of this -5. So in order to do that, I'm just going to multiply -1/5 by row 2. So I'll go ahead and do that, which is like dividing by -5. If I divide this by -5, I get 1. Divide by -5, I get 1. Divide by -5, and I get 2. I still haven't gotten 0 below this 1 value yet. So in order to do that, I'm going to take and multiply this top term by 6 and add down. So let's go ahead and do this. Multiply by 6, add to -6, I get 0. Multiply by 6, add to -10, I get -4. Multiply by 6, add to -24, and I get -12. And then finally, I need to turn this value here into a +1. So if I divide by -4 or multiply by -1/4, I can get that done. And notice what I have left. I have z, or x sub 3, whatever you want to call it. I'm going to call it z, is equal to 3. I can go back up because I know from this matrix, I know that y plus z is equal to 2. Therefore, I have y plus 3 equals -1. Whoops. Sorry, y plus 3 equals 2, and y is equal to -1. And finally, in this last row, I have x plus 2y plus 3z equals 9, and I can make substitutions. So I have 9 equaling 3 times 3 plus 2 times negative 1 plus x. This gives me 2 is equal to x. So I have 2, negative 1, and 3 as the solution of this system. So a little bit different way to solve systems. Don't need a calculator to do it, and I'll expect you to be identifying the row operations to get that done. Do your lesson summary, fill out your My Math Lab, and we'll discuss more tomorrow.